Hey, so we are starting 2.6C, which is skewness and standard deviation. And in this section, it is very important that you have a calculator. In fact, we're going to do one problem the long way just so you can see how terrible it is. And then we'll just use a calculator from there on out. And so before we get started, I want to show you something that I've posted. I emailed some of you that have contacted me about a calculator, but some of you have the exact same calculators I do, which is great. I think I said it was on sale at Target. And some of you have different ones, and that's okay too. It just kind of depends on which one it is. So I have this files tab. This is just in the Math 10 course. And if you click on how to use your TI, notice TI, really don't like Casios, but TIs are fine. So this bottom one, most graphing calculators will fit in there, the TI 83 and 84. And then this is also a popular one, the 30XIIS. And so if you have one of those calculators, I do have a file, and I think they're just a couple pages each, and you just jump to the specific topic. So today we're doing standard deviation. So if you need to know how to do that on one of these two calculators, just look for the standard deviation portion. Okay, so let us go out notes. And so we are talking about skewness first. And so here, just some words. It says, it talks about the skew, and there's not really a picture to explain it at this moment, but we do have these two little inequalities. And that's great if you are good with inequalities. I always forget which is which, so I'm going to draw a picture and I'll show you how you can tell from the picture which way it's skewed. Oh, and then this equal, the mean equaling the median, meaning symmetrical, shouldn't be the tricky one. For me, the tricky one is it less than goes with left or greater than, and does mean go on the left or the right? And so I like to look at pictures for that kind of stuff. And so here's a picture from one of my other classes. So you don't actually have this unless maybe you took Math 88. If you took Math 88, you probably have this somewhere in your notes. But I just want to put this up here for a minute, and you can screenshot it in case, or write it down. But this is what the two scenarios look like. I just wanted a computer graphic more than me writing down the pictures because my drawing isn't the best. And so skewed to the left goes up as you read this from left to right, and skewed to the right goes down as you read this from left to right. And to me, that was always confusing. Is left little on the left, or is left big on the left? And then I had a student tell me the most wonderful mnemonic device. Okay, you're going to see my drawing now. So here's a foot, toe, little toes, baby toe. And this one right here at the big toe on the inside, that would be your left foot. And that if you use your imagination, that kind of looks like this left picture. Like here's your big toe, and here's a smaller toe, and a smaller toe, and a smaller toe. I mean, if we're talking about feet, surely it looks more like your left foot than your right foot, right? So it's just the way I help remember. The left foot, the picture looks like my left foot. Opposite on the other side, skewed right, I have my big toe on the middle. Here's my whole foot. And then I have toe. Oh, this person has very pointy toes, and it almost looks like a hand. Anyways, big toe, littler, littler, littler. Don't judge me by my drawing, but use this tool. It's a very handy way to remember left versus right. And then going back, I don't need to go back, but you have it on your notes. It talks about when the mean is less than or greater than the median. And so the mean gets affected, meaning, so here, this one is skewed left. So the median is somewhere in the middle. Oops. So the median, somewhere, this is a frequency table. So the median's probably over here because you can see there's much more happening in these tall towers than on the little towers. But the mean is affected by that data, it's affected by the outlier. So the mean gets pulled, just look backwards to that picture. The mean gets pulled down with the skew. So this is the median. Don't quote me on, I'm not saying that's exactly the median, I'm just saying the median's on that side. And then the mean would be a little bit lower, less than the median. Opposite happens over here. The median, it's in the middle of all the data. So that's the median. And then the mean is going to be affected by these smaller numbers over here. So the mean in this instance is going to be larger. So skew left, I don't know why I'm yelling. Skew left means the mean is on the left. Skew right means the mean is on the right. Well, skew left looks like your left foot. Skew right looks like your right foot. I like it when I can use the same word to describe everything. So skew right looks like my right foot. It means the mean's on the right. All right. All right. All right. Let me just talk about these last two real quick. This one, this would be symmetrical because it's just a straight line all the way across. The mean and the median would be, median would be right there in the middle. So that's it. And then bell-shaped, trust me when I say we are going to talk nonstop about bell-shaped for probably like 6 weeks later on in the semester. So we're not going to worry about bell-shaped right now. All right, so looking at this skewness, we have a problem here. And if I wanted to just follow this inequality, you could do that too. So we could just write this out, and we see the mean is on the left-hand side and the median is on the right-hand side. And let's just plug in the numbers and see if it's less than or greater than. So it says the data set has a mean of 78 and a median of 69. I know that 78 is greater than 69, so it is skewed to the right. That's it. That's all we're looking for. Similarly for number 2, if the mean, so we'll put the mean on the left, the median on the right, 44 is what to 46? 44 is less than, so this is skewed to the left. Another way to think about that, if you don't like the, trying to remember the inequalities, is just think about the picture. In this picture, if this was a number line, 69, 78, the mean is on the right-hand side and it's skewed to the right. If we did this next one on a number line, the mean is on the left, so this is skewed to the left. That's it. Oh, well, that's not it, but here we go. The mean and median are both 110. So that means it is symmetrical. That's all we're going to talk about skew. Where's the mean compared to the median? All right, the big part of this section, and it's not going to feel very big, I know. I was even looking at the notes, I was like, oh man, this is going to be short. Yeah, it's not going to feel big, but this is a huge concept in this class. So today is like the first day of the rest of your life. Yay, how inspirational. We're going to be talking about standard deviation a lot forever. And this is just the beginning of it. So I'm going to write out some stuff, and it's going to seem possibly irrelevant or I'm sure it's uninteresting to some, but just kind of maybe put a flag on this page and be like, this is a big deal. I need to keep coming back to this idea over and over again. All right, so technically, well, let me just talk about this chart first. And so it talks about the standard deviation compared to the variance. So what we're trying to do is we're trying to see how much the data deviates or changes from the mean. That's what the standard deviation is. And there's another word called variance, which is the standard deviation squared. Variance comes up oh so rarely. It will come up sometimes. It's a big deal right now because we're learning the formula. but it's very easy to get from variance to standard deviation, because once you have standard deviation, you just square the number and that's it. So these are the 3 takeaways from here. Standard deviation is always positive. It can be 0, but it won't be negative. Standard deviation has the same units as the original data, and standard deviation can be influenced by outliers. So it's similar to the mean in that it can be influenced by outliers. In fact, we talk about the standard deviation and the mean together as a package set. The other package set we talk about is the 5-number summary, includes the median. So that is one package, and then that's like a minor package. And this standard deviation mean, they go together, and this is a very big deal. So I'm gonna hold off on this formula for just a minute because I wanna talk about this really important thing I said I wanted to talk about. So we have mean, and we have me not being able to spell. Okay, let's see. Oh, you know what? I have my keyboard still attached. Bear with me. This way I can get closer. Okay, so we have the mean, and we have the standard deviation, making a little table. And we have been talking about the population versus the sample. Population big, sample small but representative group of that population. So we have the mean and the standard deviation of the population, and that's different than the mean and the standard deviation of the sample. And today is the first day where that difference matters. We talked about mean in the past. Mean doesn't matter, but standard deviation really does. So I'm going to write down the symbols, and we might not use all the symbols today, but we will be using them throughout. This is the table that you should put the flag at. All right, population mean is mu. It looks like that. I have a bag that has a mu on it. I don't know if the joke's funny enough for me to show you my bag, but it is spelled M-U, in case that helps you pronounce it, mu. Okay, I'll show you my bag because it's cute. And it's really close. Okay, so I went to this conference, and obviously pre-COVID, and I got this. It was in Wisconsin, so there's a cow on it, and the cow's like, mu. Cracks me up. Okay, so that's mu. That doesn't even look like a U right here, but MU is how you pronounce it. It's a Greek letter. And standard deviation is sigma. Sigma looks like this. You might have heard of a sigma that looks like, or I think we have one down here. Nope. Well, we have, you can see what it looks like printed. That's sigma printed in terms of like typeset. This is me writing it by hand, which looks very similar. And so I'm going to just write out sigma. These are both lowercase letters in the Greek alphabet. So you might have seen a capital sigma before. That's different in that it's capital, not lowercase. Okay, so here's sigma and mu. Population uses the Greek alphabet. Sample uses the alpha, whatever numeric, whatever we use for our the regular alphabet. So the mean, I think it's called the Arabic alphabet, whatever, it's just the regular one. So the mean is called X bar. You can see that down here, X bar. And then the standard deviation is S, just the letter S. And for now, this column is the most important because that's what we're talking about, standard deviation. So knowing those two symbols, and trust me, your calculator knows the difference, knowing those two symbols is key to this homework. I feel like the skew is like nothing for you guys. You'll get the less than or greater than right away. But the sigma versus S is the tricky part. Okay, so here are the steps for standard deviation. They're kind of long and complicated. And so what I'm gonna do is I'm just gonna leave these here for you to have access to, but I'm just gonna do it. I'm just gonna do step 1 and do step 2 and so forth on the first problem that we're gonna do with this. And then you can always come back to this chart and kind of read through what we did in case you can't remember how the steps came to be. And again, we're only gonna do this once because it is painful. However, some of you out there are still stubborn and still want to use your dollar store calculators, and you might not be able to do standard deviation with them. So this is kind of your come to Jesus moment of, Do I want to do these by hand, which is perfectly fine, just very time consuming, or do you want to do these with your calculator? Okay, so for this first example, in order to find the standard deviation, we need to know the mean. And so, oops, my fan is on and my notes are blowing everywhere. So we have done the mean on the calculator. Everyone's done it. If nothing else, you can add them up and divide by the number of numbers. And I will warn you that I preloaded my calculator with 4 and 5. And so I am going to make a note in Canvas if you want to do that also. But if you haven't typed this in your calculator, now is a good time to do so, or pause the video to do so. All right, so I see from my calculator, I see that X bar equals 21.3. Okay, so now I'm going to do this with all the data points. So I like to write them in number order just because it makes the arithmetic easier. And so first I have all my X's, all my data points. So I have 15, I'm going to have to write smaller, 17, 19, 22, 25, and 30. All my data points. Okay, next I want to subtract X minus the mean. So for the first one, I'm just going to do 15 minus 21.3. So I just typed it somewhere. There it is, 15 minus 21.3, and I got negative 6.3. All right. And repeat. Subtract 17 minus 21.3. I have all the answers, but I'm doing this the long, terrible way because I want you to see how long and terrible it is. So that way you'll say, oh yes, I definitely want to use the shortcut from now on. Okay, 19 minus 21.3. 22, I can do that one in my head, 0.7. 25, or it's bigger, it's better when they're bigger, 4.7, and I thought it was better, 8.7, 30 minus 8, no, 30 minus 21.3, 8.7. So we have some positives, we have some negatives, cool. Next step is to square everything. So we have X minus X bar squared. So I just type it in. Now, if you type it in your calculator wrong, you're going to get the wrong answer. So when you type in negative 6.3 squared, you should be getting positive 39.69. If you got a negative, it's because you put this in your calculator instead of the parentheses. It is extremely important that every number in this last column is either 0 or positive. No negatives allowed, because this is what's going to give us the standard deviation. All right, negative 4.3 squared, 1849. Negative 2.3 squared, oops, I forgot to square it, 5.29. 7 is just 49, so 0.49. 4.7 is 2209. Seeing a theme with these nines. And 8.7 squared is 75.69. Okay, so just to go back, in case anyone is following these steps, we did this, we've subtracted, that's a big check mark, we squared. We're only 2 steps through, this is very long. All right, so now we need to add everything that we just squared and then divide by, well, we're gonna come back to the divide by in a minute because it's gonna kind of depend on what we are doing. So we are going to add these all up. I will do this one because I already did it. So we're going to add these all up and we get 153.34. And now we need to either divide by n if we're talking about the population, or divide by n minus 1 if we're talking about a sample. This first example is not super clear, but I'm telling you because I wrote it and just forgot to write this word. It is a sample. On the homework, it'll either say it or you'll be able to figure it out. And in example 5, I'll show you how you can figure it out. Okay, so since it's a sample, we're dividing by n minus 1. So we want to do, we're finding the sample, so it's S is 153.34 divided by, what was n? N is the number of numbers. 1, 2, 3, 4, 5, 6. There's 6 numbers. So n minus 1 is 5. And finally, I put 153.34 divided by 5. And I get 30.668. Did I divide that right? Let me double check. Okay, so I'm sure there's a few of you out there like already raising your hand like, oh, you made a mistake so long ago. I totally found it. Thank you. This is why I much prefer being in person, because then I can actually hear you tell me instead of you yelling at me from your house, you made a mistake. This is it. I know you already saw it, but I want to just get it down there. 3.7. Why? Because I was trying to subtract in my head. All right, that changes this number to 13.69. See, I wrote it all out, but I was trying to show you how painful it was. Obviously, it's painful. The chance that you can make a mistake is just painful enough as it is. All right, so I have 13.34. I'm dividing by 5, and I get 30.668. And just notation-wise, I did make one small mistake. This is actually S squared, because this isn't even the answer. All right, let's go back and just talk about what we did. So we added up everything in the column, and then we divided by n minus 1 because it was a sample. And now we need to take the square root, because right now what we have is called the variance. So if the question said, what is the variance? We would stop right here. That's the variance right here. But since the question asked for the standard deviation, it's going to be the square root of that number. And the square root, there's my square root button. Oh my goodness, I totally messed up my calculator. Okay, clear. I have the square root of 30.668, and I'm getting 5.54-ish rounded. In fact, we probably put 5.5 for the standard deviation just to go one data point over, but this is kind of a mess of a problem anyways. The units are the same for standard deviation and the problem. This had no units, and so on the next problem, we'll start using units. But let us look at our calculator to give us some better information. Okay, so either put this list in right now or you already have it, and do our favorite stat button, one variable stats, get that list going of, you know, this one, our favorite that I can never figure out how to show you. Oh my goodness gracious. Okay. It's not my day for technology. You know, the one that says n equals 1, n equals 6, and tells us x bar. We find the mean and median and all that stuff on here. Anyways, the third one down says S. In fact, I think there's an X on, well, on my calculator there's an X. It's not necessary to write, but just to match it up with your calculator. That's what it looks like. And rounding gives us that same, not that number, but 5.54 number that we just got. Way faster. Oh my goodness. I hate these. No, I actually love standard deviation. I hate doing them by hand. So hopefully I have convinced you that they're terrible to do by hand and that you're either like clutching this, kissing it, thank you so much for existing, or you're like smoke trails out the door to go get a better calculator if you can't figure out how to do it on yours. And as always, you can email me if you're having issues, but just know that some calculators just can't do it. And it kind of stinks. But yeah, graphing calculators for sure can. Okay, here we go. Now here's Sam. It's 20 rose bushes. I'm gonna do this all in the calculator, no more by hand. So this little sidebar. This last problem, 6 numbers, and it took that much. Number 5 has 20 numbers. No. I do not want to find any of that by hand for those 20 numbers. Okay, so like I said, I already pre-typed my data. So I'm gonna go in, I typed it under list 2. So I'm gonna hit stat and make sure I go to list 2. And then just one little problem, because some people are like 3.06, write it down, I'm done. The problem is, this is what's on my calculator. I have S, which does say 3.06, but if you go down 1 on my calculator, it's the 4th option, it says sigma equals 2.98. And this time we have enough information to know for certain which one's the right answer. Sam has 20 rose bushes. That's it. That's the whole population is 20 rose bushes. And somebody went through and counted the number of flowers on each of Sam's 20 rose bushes. It doesn't say that, but it does say each bush, and you can count and see that there's 20 pieces of information there. So this is a population problem. Each of the 20 bushes makes this a population problem, and a population problem is sigma. So there will be some problems on the homework, and you're gonna be super excited and you're gonna just put S because that's the first one you see on your calculator. You're gonna get it wrong. And that's where you, wait a second, was this a sample or was this a population? So that's the only difference between S and sigma, sample versus population. And you can see how important it is because it gives you the totally different answer. If you did the sample number, you would get it totally wrong. So just make sure you're asking yourself, is this a sample or is this a population? Okay, finally, and then we'll do a couple word problems. The variance. So this one feels like there's not really that much information because you don't really need that much information. It tells us that the standard deviation is 7.54. Now, I'm just calling it S. In this case, it doesn't matter because I'm not calculating. The standard deviation already exists. So if you feel more comfortable, you could just call it SD for standard deviation if you want. You don't have to call it S if it confuses you, but it doesn't matter because it already exists. Okay, I guess I'm calling that forever. All right, there we go. So to find the variance equals the standard deviation squared. So I'm going to square both sides, and I have 7.54 squared equals, and there's a lot of numbers, but we're talking about money, so it's very easy to know what to round to. And so the variance is $56.85. I just round to the nearest penny because it's variance. And technically it's squared. But we don't really say dollars squared, and usually the computer helps you out with those units. So, but that's how you know what number to round to for the decimal. I almost said, any questions? Like you would answer me, and I'm not just in my room talking to my dog. Okay, class 2. The importance of standard deviation, or the important properties. Now, I've already said all these 2 pages ago, but they're so important that I put them down again. Standard deviation is always positive, and it will be 0 if all the data values are equal. It gets larger as the data values spread out. Deviation means like different or change in something, how much it's changing. And so if everything is the same, there is no deviation. They are all exactly in line. As things spread out more, the deviation gets wider and wider and wider because the data is more spread from that middle. So the standard deviation really is talking about how far from that middle are we. If you don't have a firm grasp on standard deviation today, don't even worry about it. What you really need to take away from this video is when to use S and when to use sigma. And then we will be working much more on standard deviation in the future. It has the original units, the units of the original data, and it can be influenced by outliers just like the mean. So for number 7, it says, on average, which player, I can't read it, so it's stuff on my screen. On average, which player is the higher scorer? So it doesn't tell you which one is the mean and which one is the standard deviation. So I will tell you if you can't tell. So let's think about 2 NBA players. What are they probably going to score in a game? 27 points and 31 points? Or do you think that NBA players, like most of them, just score 6 points in a game? Now, we're not being technical here. We're not saying, you know, like I'm sure there's people that only score 6 points. That's fine. But this right here is going to be the mean. That's going to be the average points scored. And so people will score, like player A, he scores 27 points per game with a standard deviation of 6.6. So that's almost like, not exactly, but almost like saying he scores 27 plus or minus 6.5, somewhere around there, somewhere in that range. Whereas player B scores 31.5 points per game, plus or minus 8 points. That is a very vague, untechnical definition, but it kind of puts us in the ballpark for today. We'll get a much better definition later. Okay, so which one was the higher score? This guy is the higher because 31 is higher than 27. Which one is more consistent would be this guy, more consistent, because his points didn't change as much. It was within this plus or minus 6.5 window. Player B doesn't even fit on the screen. Player B had a plus or minus 8.5 window, so he had much more variety in his scoring. So A was more consistent. All right, last one, little packets of saccharin, which I think is sweet and low. Maybe it's equal, one of those is saccharin. But it gives us the mean and standard deviation, and you can definitely see which is which here because the notation is here. But it says which one consistently produces extra saccharin in their packets. So looking at how much they make on average, this 26 compared to that 0.1, this one produces the extra. Because on average, they're over 2 tablespoons by that 0.026, whereas company B is a lot closer to 0 or to 2. All right, which company fills its packets more consistently? So here we're comparing that 22 to the 19, and this one has less variety. It has that smaller number, so this one is more consistent. Okay, we're done with chapter 2. Hang on to the standard deviation stuff, especially because some people are like, took the first test, throw my stuff away, start over on the second test. No. This section, especially the standard deviation, but also the mean, even population sample, all that stuff is coming back in the next test and then, you know, all the way throughout the semester. So hopefully you have this notebook that you're working on and you just keep everything, and then yeah, burn season will be lifted by the time the semester's over and we can all have a s'mores or something. I don't know, but hang on to it for now. All right, I will see you in the next video. Bye.